Hello, and welcome to today's video on Chapter 1, Section 4, Formulas for Linear Functions for Precalculus. Students, remember that you're to watch the video, summarize the video, and write down any questions that you have about the video. Please indicate time stamps so that I'll know what you're referring to, but let's start. So today we're going to talk about formulas for linear functions. From middle school, you already have a good idea about what a linear function is, so we don't have to spend a lot of time on that. But today we're going to talk about the different ways to represent a linear function. And before we can talk about that, the first thing we need to know are two very important components of every linear function, which can be indicated by their graph. If we take a look here, every linear function, and I can draw a whole bunch of different linear functions, but what they all have in common is what they possess. And what they all possess is, number one, a slope, which represents the steepness of the graph. And that slope can be calculated by change over y divided by change over x, or rise over run. And you guys know that from middle school. And as you can see here, these lines on this graph all have different slopes. Some are positive, some are negative. Some are zero. I can make this a zero slope. So every line has a slope. Also, so that means we need to include the slope in the representation of the line in a formula. The second thing that every line has are points on the line. And all we need is one point to represent information about the line. So two important components of a line is the slope and a point on the line. And this point is indicated by the terminology x naught, y naught. And we're going to take a look at how to write the equation of a line. Now, when I say the equation of the line, I want to point out that there are multiple ways to represent an equation of a line. And we're going to look at three very popular formats that you guys may be familiar with from earlier on. Those formats are, we have the slope-intercept, the point-slope form, and the standard form. And I'm going to write them down just so that you have a good idea about what they are. So we have, let me use my pen. Slope-intercept form looks like of the form y equals mx plus b. Now your textbook uses the form y equals b plus mx, and that's perfectly fine. The constants are the slope, which on a line it always stays the same. And in this case, b represents the point where the graph crosses the y-axis. Okay, so an example of that, and you guys know this from middle school, would be something like y is equal to negative 2x plus 3. Okay, so that represents a line that has a slope of negative 2 and a line that crosses the y-intercept at the point 0, 3. Now, there's another form that you may not have learned about in middle school, which we will be using a lot, which is the point-slope form. And the point-slope form looks like this. Y is minus y naught is equal to m times x minus x naught. And it means exactly that. Point being the coordinates of a point on the line, and it doesn't have to be the y-intercept. It can be the x and y coordinates of any point on the line. And then, of course, m represents the slope. And to leave it in this format is perfectly fine. So an example of that format would look something like this. Minus 4 is equal to 1/2 x plus 1. In this case, this line has a slope of 1/2. And then it crosses the point, not at 1, 4, it crosses through the point negative 1, because x plus 1, it can be rewritten as x minus negative 1. So it crossed through the point negative 1, 4. So again, this is an equation of the line. Now I can easily change the format and go from point slope to slope intercept, but it's going to be very helpful for us to deal with the point slope form. Okay. Now let's take a look at another popular form. And this form is the standard form. And the standard form is really helpful when you're writing the equation of a line from a word problem. So let me change that, sorry. Ax plus b y equals c, where we have constants being a, b, and c. Something interesting enough, I can change the standard form to the slope-intercept form by letting the slope be calculated as m is equal to the opposite of a divided by b, and the y-intercept is equal to c over b. Okay? And so that is a format of how we can change from standard form to slope-intercept form. So a good example of that form would be if you're reading a word problem, and let's say you're trying to figure out how many people bought movie tickets. And so if they say, well, so-and-so, the group went to the movies, and each child ticket cost $5. Oops, and let's see. And each adult ticket cost $7. And the group had to pay a total of $100. This would be an example of the equation of the linear relationship between the number of child tickets and the number of adult tickets in the form of the standard form. So that is when it is beneficial. Now, why are we talking about these forms? These forms are important because depending on the situation, you need to come up with quickly a way to represent the linear relationship between two variables. And we can use any of these forms to represent that relationship, but some come easier than others. And it depends on the information that they gave you. So if they give you the slope of the relationship, or the relationship, the rate of change of the relationship between x and y, and they give you a point, then I would use, of course, the point slope form. But if, which is this form right here. But if they gave you the rate of change and the y-intercept, then you could also use the slope-intercept form. If they didn't give you the rate of change, but they did give you the rate of change per variable, then you could use this standard form. So this $5 a ticket for children, $7 a ticket for adults, equals some constant that can be represented in that format. So I hope this helps. I encourage you to work on the practice problems as well as review the textbook section 1.4. That's it.